Hey everybody, it's been a long time since I've seen you. Hope you're doing good. It's a great day here. I'm going to talk to you a little bit about simplifying radicals. I understand a couple people are having trouble with that, so let me show you a few things. Maybe I'll make it a little bit easier for you. Let's go to work. Simplifying radicals. Remember, radicals are square roots. Hey, what times itself gets me this number on the inside? We've been talking about the perfect squares all year. Like, I don't know, 9. What is the square root of 9? What times itself gets us 9? And that's 3. Remember our perfect squares? We got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. We had tons of quizzes on those this year. Well, we're going to use those or factor trees to help us simplify radicals. Okay, if you were given one of these numbers underneath a radical, you should be able to know their square root really simple. That's where I am as we start this process. So let's take a number, for example. I don't know. Let's just make one up here. The square root of 28. Now, there's two ways to think of this. Okay. First, we can start by thinking about this list. Are there any of these numbers on this list over here that go into 28? Well, yeah, 4. I could rewrite that as 4 times 7. That's another way of writing 28, right? 4 times 7. Then that could be rewritten as the square root of 4 times the square root of 7. But now we know the square root of 4 is 2. So 2 square root of 7. That's one way of simplifying a radical. What way is it? Well, you just look at the radical and you see if there's a perfect square that can go into that radical, and you divide it in and then take the square root out. Let's try another one. Let's say I have, I don't know, the square root of 50. Okay. Well, what perfect square? And sometimes there's more than one perfect square that'll go into it. So you want to make sure you always take the largest one. So what's the largest perfect square that goes into 50? Well, it's right there, 25. So I could rewrite this as 50 is the same thing as saying the square root of 25 times 2, right? Because 25 times 2 is 50. So that's the same thing as the square root of 25 times the square root of 2. And we know that the square root of 25 is 5. So that's 5 square root of 2. So there's another way for us to simplify radicals. Not another way, but that's how we simplify radicals. I'm going to give you one additional example. Let's say I have the square root of 162. What perfect square goes into 162? Well, there may be more than one, but the first one that I see, of course, I'm the one that made up the problem, so that's why I know it, is 81. 81 times 2 is 162, correct? So the square root of 8, that's the same thing as saying the square root of 81 times the square root of 2. Well, we already know and have said multiple times, square root of 81 is 9. So that's 9 times the square root of 2. So there's one method for simplifying radicals, and I hope you like that method. And I have always liked that method, but I want to show you one more because not everybody likes that particular method. Here is the second method. Now, before I get into the second method, you may remember doing a factor tree or a prime factorization tree. And if you do, that's good. So let's take, let's take 12. Factor that apart until you get all prime numbers. Well, give me 2 factors of 12. Well, I could have 2 and 6. And then that 2 is prime, so it's good. And then 6 can be factored apart to be 2 times 3. Good. Now you see how there's 2 2's there? That's going to be important. Since there's 2 of them, we know that 2 times 2 is 4. So that's the same thing as the square root of 4, which is 2. I'll come back to that in a second. Okay. But this 3, there's only one of them. Since there's only one of them, we would leave that inside. So this could be written as 2 square root 3. Why is the 2 on the outside? Because there's 2 of them. Let me take this same number 12 and break it apart with prime factorization another way. We could think of 12 as 3 times 4, right? And then 4 could be broken apart to be 2 times 2. See, we have 2 2's, so I circle those, and I only have 1 3, so I put a box around that. Anytime I have something that appears twice, it'll go on the outside, so that'd be 2 times the square root of 3. And this is using a prime factorization tree to simplify a radical. So let's use that process here. Now, these first numbers that come out don't have to be prime numbers. You just keep working down until you have all primes. So 2 numbers that multiply to get me 28. Well, 2 times 14 is 28, right? Well, 2 is prime, so I can leave it there. And then 2 times 7 is 14. So these 2, there's 2 of those, so it'll go on the outside. And there's only 1 7, so it'll go on the inside. So simplified radical is 2 square root of 7. Hey, it's the same thing we got there. Let's try it again on 50. I could go 2 times 25, right? And then 25 would be 5 times 5. Hey, anytime I have 2 of them, it's going to go on the outside, just 1 of them. And then if I only have something by itself, it goes underneath the radical. Whew. Are we getting this? So this is the second way to simplify a radical. So 162 is even, so I know 2 is going to go into it. It's going to go in 81 times. And then that could be 9 times 9. And then 9 could be split apart to be 3 times 3. And this one could be 3 times 3. So this 2 over here is by itself. And I've got a 3 here and a 3 here. So that's a 3 times a 3. So that's a 9 square root of 2. And notice that's the same thing I had right there. So there's your 2 methods of simplifying radicals. And that's just with numbers. Let's add in some variables here. Let me just go straight to variables. Anytime that we're taking a square root of something, say we have the square root of x to the 6th, all we have to do is take the exponent and divide it by 2. So in this case, it would be square root of x to the 6th is x cubed. The square root of x to the 12th would be, anybody? Yeah, 12 divided by 2 is x to the 6th. How about the square root of x to the 4th? Yep, x squared. How about the square root of m to the 8th? Yeah, m to the 4th. We're getting that. That's no problem. Here comes, sometimes people have a difficulty with this one. What about if I have x to the 7th? Well, we could rewrite that as x to the 6th times x, right? And then this x to the 6th, we already know we can pull out x cubed. And we have to leave this one inside by itself. Okay, so how about the square root of x to the 9th? Now, that would be x to the 4th times the square root of x. Notice here, I have to break that apart because this is odd. I got to break it apart to be x to the 8th times x. And then x to the 8th is x to the 4th. I hope that you're getting it. Now let me put these 2 things together. Let's say I have 32x to the 6th. What is the square root of 32x to the 6th? Let me start with my 32. And I can do this one of 2 ways. I can either think what perfect square goes into it, or I can do the prime factorization tree. Okay. A lot of times they're very similar, but give me factors of 32. I got 4 and 8. Well, 4 is not prime, so I keep factoring down to be 2 times 2. And then Uh, 8 is 2 times 4. And then 2 times 2. Now, I got 1, 2, 3, 4, 5 2s. Well, these two can go together, and these two can go together, and that one's by itself. So that's 2 times 2. That's 4. Square root of 2 would be the prime factorization of 32. But then I got to deal with this x to the 6. Well, what's a square root of x to the 6? That would be x to the 3rd. So when I finish this up, it would be 4x cubed times the square root of 2. Whew! How you doing? Struggling? Understandable. This is not necessarily an easy task, but if you break it apart and deal with both sides, it's not that bad. Let's try one more. And then I hope that this will help you. Let's say I have, what is a square root of 98 x to the 4th y cubed? Okay, let's start with the 98. I'll erase what I have here so we can just focus on this one problem. Let me break it apart. Let me deal with the 98 first. Okay, 98. I can break that apart. I know it's even, so 2 goes in. 2 goes in 49 times. Well, 49 breaks apart to be 7 times 7. There we go. That's 7's together. So just factoring and simplifying the radical of 98, I'm going to have 7 times the square root of 2. Oh, that was good. Now if I take the x to the 4th, the square root of x to the 4th. Now that one's an easy one because it's even. So it'll be x squared. Well, what about the square root of y cubed? Well, it's odd. So I have to rewrite it as y squared times y, right? And I can take out the y squared. So it leaves me with y square root of y. So now I put all 3 of these back together. 7 and x squared's on the outside. 7 x squared. And I have a y on the outside. And what's left underneath? I got a 2 and a y. So there you are. That is simplifying radicals. If by prime factorization, or in most of these cases, even when I was doing prime factorization, look, there's a perfect square and it goes in there 2 times. So that's another way of thinking about it. So anyhow, I hope that helps you figure out how to simplify radicals. Have a great day.